Let's flex our math skills just a little bit more now with the conversion of units. Often we'll need to change from one measurement system to another, say from the SI system to the British system or vice versa, or maybe we're just converting within the CGS system to the MKS system. But sometimes we need to convert units because we have a measurement in some system of units that we don't want to use, or we want to use a different system of units. Let's say, for example, we have a speed measured in meters per second, and we want to convert it into miles per hour. We're going to use conversion factors in order to convert this from one to another. And in this case, we'll need two conversion factors. We'll need to know what is a mile equal to. And I know that a mile, if you run track, you know that a mile is equal to 1,609 meters, just a little bit more than 4 laps around a 400-meter track. And then an hour, well, an hour is 60 minutes with 60 seconds per minute, and so that's equal to 3,600 seconds. Those are two conversion factors that I need to know in order to make this conversion of units. These are conversion factors. Sometimes I will provide you with those, like for example, I would definitely provide you with this conversion factor, but this one is one that I would expect you to know. I expect you to know there are 60 minutes in an hour and 60 seconds in a minute. So if I wanted to convert 24 meters per second, I'd say 24 meters per second. And again, this is maybe somewhere where somebody has set up this ladder, like you might have seen that in high school. I'm not going to do it that way. I'll multiply it times my conversion factors so that the units cancel out and leave me with the appropriate units. So let's take the miles to meters first. I have meters in the numerator, so I'll have to put my conversion factor with meters in the denominator, and then I'll have miles up here. So I know that 1 mile is 1,609 meters. Now let's recognize what has happened here is that I'm canceling out that unit. I don't cancel the numbers, right? But I cancel out the units, and it leaves me with miles in the numerator. And now I need to get rid of my seconds, so I put seconds in the numerator and hours in the denominator. And again, that gets rid of this seconds here and leaves me with miles per hour. And the number of seconds in an hour is 3,600 seconds per 1 hour. And then if I multiply these, I get 54 miles per hour, or you might say mph. Okay, so that's a conversion of units. That's a known that's a unit that we know, but you can use unknown units too. Like for example, there's a bridge in between Harvard and MIT across the St. Charles River, and for many years, one of the fraternities at MIT has measured that bridge by the height of their shortest member. And back in the 50s or 60s, when they first started doing this, that shortest member's name was Oliver Smoot. And if you go to that bridge today, you see the measurements of Oliver Smoot's height laid out on the bridge. So every 5 or 6 feet, there's a spray painted mark that shows another measurement of Oliver Smoot. And it's something like 264.5 smoots to cross this bridge. Now, let's say that I wanted to convert the unit of smoot, which is based on this guy, Oliver Smoot. By the way, he won the Nobel Prize later in his life. But if you wanted to measure the length of something in smoots, then you would have to know what is the conversion factor. And so I'm telling you, in this length of 364.4 smoots, that there are 125 meters, say the length across the bridge, for example. So how many smoots is 225 meters? Well, I have the conversion factor of smoots to meters, so all I have to do is multiply it. Meters in the denominator, that will get rid of these units, and smoots in the numerator. So I have 364.4 and then 125 meters, and then that's going to leave me with 660 smoots. Okay, let's look at some metric videos, or metric conversions. You can just sort of do this here at the bottom. Let's say that I want to convert from grams to kilograms. You will, by the way, need to know a few metric conversion factors. I'll just write down the ones that you need to know here. You'll need to know milli, centi, and kilo. The abbreviations for these are lowercase m, lowercase c, and lowercase k. We might see other metric prefixes as we move through the semester, but I'll explain those to you as we come to them. Milli is 10 to the minus 3, or 1 over 1,000. Centi is 10 to the minus 2, or 1 over 100, and kilo is 10 to the third, or 1,000. So those are our metric prefixes that I want you to know for right now. So say, for example, I want to move from grams to kilograms. So I have 243 grams, and I want to convert that into kilograms. Well, I know that in 1 kilogram, there are 10 to the third, or 1,000 grams. And so I would say, I do my unit conversion, and that cancels out, and this would be 0.243 kilograms. And in fact, as you get good at this, which you will, you'll realize that if I'm changing my units in the metric system, it's actually quite simple to go between units, because all I have to do is move my decimal place over. So I'm starting right here. When I'm going from grams to kilograms, because I have this 3 right here, I just move that decimal place over 3 spots, and that's what I got right here. So say, for example, if I wanted to convert centimeters, 25 centimeters, to meters, what would that answer be? Well, let's see. I know, first of all, that my meter is going to be a smaller measurement, because there are 100 centimeters in 1 meter. So the number here has to be smaller than 25. Right? It's not going to be 250 meters or 2,500 meters. So I can say then that my decimal place, which is right here, is going to move 2 spots over, or 0.25 meters. And I get that from here. Now, if you want to do it the longer way, we can say 25 centimeters, and then convert that into meters. In 1 meter, there are 100 centimeters, and then that would be 0.25 meters. You'll get the hang of this as we move along. And that's the end of Chapter 0. So Chapter 0 is not in the book. However, you will be tested on it both in quizzes and the exam, and there's some good foundational math tools that we'll use throughout the semester.